A lecture on the physics of baseball presented by Dr. Alan Nathan from the University of Illinois. I've always loved baseball, and I always think it's really neat when we get to apply the lessons we learn in class to real-world situations. So I found his talk very interesting. Dr. Nathan covered two main points in his talk, one dealing with ball-bat collisions in baseball and one dealing with the flight of the ball once pitched. So when it comes to ball-bat collisions, a ball actually loses about half its speed once it hits the bat because of a transfer in momentum. But the bat actually slows down as well because its momentum has a different direction than the ball. So when the momentum gets transferred, it actually pushes the bat in the other direction, which slows it down. And then there's an equation that relates the speed of the batted ball to the speed of the pitched ball and the speed of the bat, and something called the collision efficiency. So the velocity of the bat is actually more important than the velocity of the pitched ball. And you can kind of think about this intuitively because when you bunt a ball versus when you swing at it, there's a big difference in the speed of the ball. So yeah, the speed of the bat is like more important than the speed of the pitched ball by like a factor of 6. And then the collision efficiency deals with two things, the weight of the bat and something called the coefficient of restitution, which kind of deals with like the bounciness of the ball when it hits the bat. If you're wondering if wood or aluminum makes the ball go faster, they're actually about the same because their differences in weight are balanced with their differences in coefficients of restitution. And then the part of the bat you hit the ball with actually matters as well because there's like a certain sweet spot on the bat that if you hit it, it reduces the amount of vibrations in the bat, causing the ball to go the fastest. So in terms of the flight of the baseball, when a ball gets pitched, there are a couple forces working against it. The drags will slow it down, and then something called the magnus, which deals with the spin of the ball, as well as gravity, keep the ball from going in a straight line. So with these forces, normal pitches are pretty predictable, like we have a pretty good idea of where they're going to fly over the plate. But when it comes to something called the knuckleball, there's no way of predicting at what point over the plate it will fly because its trajectory depends on the number of revolutions as well as its axis of spinning. Dr. Nathan actually did a really neat research project involving a wind tunnel to study the effect of the knuckleball, and it's actually like a chaotic system. Like one tiny little change when the pitcher releases the ball can have a really big effect by the time it ultimately gets to the plate. And then a final note on the flight of the baseball is that balls fly faster at lower pressures, which explains why there's always way more home runs up in the Rockies baseball field in Colorado. So I was very impressed with Dr. Nathan's talk, and he encouraged us to visit his website, which I did. And on his website, there was a link to a really cool research paper done by another professor, Dr. David Kagan at California State University. And his paper dealt with the physics behind stealing bases. And so he actually developed like a kinematic model that talked about the most efficient way from getting to base. So I thought that was really cool. Nathan's talk also inspired me to look at the physics behind other sports besides baseball. One of which is Quidditch, the best sport in the world. And so I went online and I was looking at some websites, one of which, a very reliable source, fanfiction.net, had some comments by a username called Mosh Pit Stories. And this dude had some pretty interesting things to say. Basically, Quidditch is physically impossible because if you're on a broomstick and you're traveling at 150 miles per hour, which is how fast a firebolt can go, and you try and grab a snitch out of thin air, it's going to go straight through your hand. It'd be like if you were driving in a car at 150 miles per hour and you stuck your hand out the window and tried to catch a golf ball. Like that thing is just going straight through your hand. Not to mention the amount of pressure that's going to be exerted on your groin area when you're flying on a narrow piece of wood like that. Man, it's just going to be painful. So really, there's got to be other forces at work besides physics when it comes to Quidditch, and obviously that is magic. magic. Alright, well I hope you enjoyed this video and learned something new. Take care.